So for this first question, I think some of you might have gotten a little confused by the use of the word counting number. Basically, a counting number is just like a whole number. So a number you'd count with, like 1, 2, 3, 4, etc. So really all this question is asking you is to figure out the answer to this multiplication problem and then add up the digits of that answer. So sum means to add. One of the quickest ways to multiply this number quickly in your head without a calculator is to break it down. So you know that 2 times 5 is 10. So that's really 10 times 10 times 10 and 7 times 7. So you know that 7 times 7 is 49. And you know that 10 times 10 times 10, 3 zeros, so it's 1,000. So then really all you have is 49 times 1,000. But really, 1,000 times 49, you're just going to get 49,000, right? So this number doesn't actually impact the sum of the digits in any way. So really, the sum of the digits is just 4 plus 9, which is 13. So that's the answer to the first question. Again, I think some of the language might have messed some of you up. This next question is, depending on, especially if you're in grade 5, you're at a bit of a disadvantage because you haven't learned much with fractions. The word of just means to multiply. So basically this is saying take a half times 4/5 times 9/10 times 75, or you can write it as 75 over 1 and multiply that. Now, those of you that are learning fractions, and even if you haven't learned fractions, one of the easiest ways to multiply is to simplify as you go. So instead of multiplying 1 times 4 times 9 times 75 on the top, and 2 times 5 times 10 times 1 on the bottom, and then simplifying, it's easier to simplify as you go. So for example, you know that 2 goes into 2 once and 2 goes into 4 twice. You know that 2 goes into 2 once and 2 goes into 10 5 times. You know that 5 goes into 5 once and 5 goes into 75 15 times. You know that 5 goes into 5 once and 5 goes into 15 3 times. So notice that you can cancel out things that have already been canceled out. In the end, what you're actually left with is 1 times 1 times 9 times 3, and 1 times 1 times 1 times 1 on the bottom. And so really, when you multiply the tops, you're really just multiplying 9 times 3, which is 27. And when you multiply the bottoms, you just get 1. So 27 over 1 is just 27. So again, some of you that are not as familiar with multiplying fractions, and that's probably most of you, would have found that question a little bit challenging. Let's look at the next one. Now this one's quite an interesting one. There's a couple of different ways of doing this one, and I think a lot of you probably just kind of played around and guessed. I'm not sure. One of the things that I did when I looked at it, I focused on these bottom two equations first. And I noticed that it was just a combination, both were a combination of triangles and squares. So what I noticed right away was if I added those two together, if I put them all like in a bag or something, I would end up with 3 triangles, 1, 2, 3, and I would end up with 3 squares. And again, if I added all those together, if I added all those shapes, then I also have to add what they equal. So those together will equal 27. Now when I do that, I notice if 3 triangles and 3 squares is 27, then 1 triangle and 1 square must be 9, because all I did was divide everything by 3. So that tells me something right there. That's really important to know. The other thing that I noticed, and I think probably a lot of you might have noticed this, is that these two equations are virtually identical, except this one has 2 squares and 1 triangle, and this one has 2 triangles and 1 square. Notice that they're 3 apart. That means that the square, because this one's bigger, the square must be 3 heavier than the triangle. So if I know that triangle plus square has to equal 9, and I know that the square is 3 heavier than the triangle, what does that tell me then about the square and about the triangle? Well, it tells me that the square must be 6 and the triangle must be 3. So now I can go back up to the top one at this point, and I can say, okay, 3 plus 6, that was 9. Well, what must the circle be then? Well, if together they must be 16, and I'm already at, if these two are 9, then I know that the circle must be 7. Then I can go to this final thing here and think, okay, 7 plus 6, that would be 20. And my answer to that question is 20. So this one was also kind of an interesting one. And again, I don't know if you were maybe thrown off by some of the language. Again, sum means to add. So we know that page numbers with 5 are erased. So that means we're erasing 5. Whoops. Erasing 5, 15, 25, 35, 45, 55, 65, 75, 85, and 95. We also know that we're erasing 50, 51, 52, 53, 54, 55, 56, I'm going to go backwards here, 57, 58, 59, and that's it. Now, we've counted 55 twice, so we got to get rid of it on one list. So I'm going to get rid of it there. So really all you need to do is add up all of these numbers that I've just written down. Sounds really easy, and yet it's harder because you don't have a calculator. So how are you going to do that? So if you're trying to just add up in a traditional stack and add, you're going to probably make a mistake, or it's going to be a lot of numbers to have to keep track of. So what you always have to do, math, remember, is all about finding patterns. It's finding relationships between numbers. That's kind of the most exciting thing about math, is figuring out how can I do this in a faster and easier way? Where's the pattern? What you might notice, or you'll notice here, is I can actually pair these up. If I pair up 5 and 95, I make 100. If I pair up 15 and 85, I also make 100. And that makes 100, and that makes 100, and that makes 100. So I actually have 5 pairs of 100. Well, that's really easy to do in my head. So I just added that whole list by knowing that pattern. Now let's look at these numbers, and I'm going to notice something very similar. I can pair them up. This time, each of those pairs equals 110, and I have 4 of those. Okay? Again, you can break this number down. 4 times 100 is 400, and 10 times 4 is 40, so that's going to be 440. And then I have this 50 left over. So I've got 500 plus 440 plus 50, and I end up with 990. So knowing patterns and how to pair numbers and do some quick mental math allowed me to get the sum of these numbers really, really quickly. So actually, what seems like a hard question actually becomes something pretty easy. So just something to kind of think about with numbers. So let's look at this last one. There again are a couple different ways of approaching this last one, and some of you are going to notice some things about it. What I'm going to do is probably go over the one that most of you tried to do. Most of you probably tried to find the area of each surface that you saw. And so what you're going to do, so this is asking you, face means each surface that you see. So you're going to notice this face here that's 3 by 3. There's going to be one there. There's going to be one back here that you don't see, and one underneath that you don't see. So 3 by 3 has a surface area of 9, and there are 3 of those. So far we're at 27. Okay? Then you've got these L-shaped surfaces. So let's look at this L-shaped surface. You've got one there, you've got one there, and you actually have one right in here that you don't really see, but it's on that side there facing. So you've got 3 of these L-shaped surfaces, and each one has 5. So you've got 5 times 3, and we're at 15. Okay? Now, what else have we got left? Okay, so we've got some 2 by 2 surfaces left. And I'm going to show those 2 by 2. I'll try to show you with red. So there's one that's right in here. Part of it's blocked off. And then there's one that's right there. And then there's one that's going to be right in that part that you can't see. Each one is 2 by 2, which is 4. And there are 3 of those, which will give us 12. So really we've got 27 plus 15 plus 12, which is 27 plus 27, and we get 54, which is the answer. Now, one thing that some of you might have noticed, and actually which makes it really fast, is you might have noticed that this shape here also had some 2 by 2 surfaces. When you took it away, you actually didn't change the surface area of this shape because you still had the same surfaces. Like this 2 by 2 surface here that you took away is here. It's in that spot. And then this 2 by 2 surface there is actually that one right there. And the one that's on the the one that's on the top becomes the one that's on the bottom there. And I know that's kind of messy in how I'm drawing it. And if you don't understand, that's totally fine. You don't have to do it that way. But some of you might have noticed that removing that shape didn't actually change the original surface area. And the original surface area was 3 by 3 times 6, which gives you 54. So that was just another way of approaching the question.